wanted to make a few remarks about the infrastructure we'll be using for the lab sessions, and that's called FutureGrid. FutureGrid is a project funded by the National Science Foundation and is part of the Exceed cyber infrastructure. And it is essentially a test bed. It's aimed not at production computing, but at testing ideas and software, and also for doing educational activities like this. It supports many classes and such things. And it's unlike, say, parts of Exceed. It runs interactively, and it has many users. So actually 968 was before you lot bragged, so it's probably there must be maybe 1,100 users formally logged in. It has multiple projects. You will see that you were asked to register with what the project corresponding to this summer school, and there is a paper which we can make available. We should add that to the Tumblr homepage to describe FutureGrid. So FutureGrid is not itself a cloud. It is something that can be configured as a cloud. As Michael emphasized, we do not just want to look at virtual machines. We might want to look at HPC environments with bare metal, with the operating system loaded onto that, and so FutureGrid supports either virtual machines or non-virtualized environments, and each of those is an image, and you can either load images with hypervisors as cloud-like images, or classic Linux or Windows images that support traditional computing. FutureGrid is quite small. It only has 4,400 cores. It has a dedicated network, and it also has a device that inserts faults if you want to do some testing about network faults. FutureGrid has many partners who work very hard to bring it up. Indiana, San Diego, Chicago, Florida, USC, University of Southern California, Tennessee, Texas, Virginia, and also Dresden. And the 5 sites in red have actual hardware. The other sites do software, or in the case of Tennessee, benchmarking. And here's a picture of FutureGrid. So the shows the network and the various sites across the country. It has distributed sites because some of the testing it wants to do involve running distributed computing. So it supports grids or clouds, or in fact HPC on modest numbers of nodes. Michael pointed out that people are now adding more disks on each node. The original FutureGrid systems did not have much disk on each node. The more recent systems have 12 terabytes of disk on each node, precisely so we can support things like HDFS efficiently. Here's a picture of FutureGrid. Those are the various sites across the country. And here's a list of that hardware. The last 3, Bravo, Delta, and Echo, those all have 12 terabytes of disk on every node. As you see, the total is around 4,400. And there is storage at each site, and there is traditional support. You've logged in, hopefully, to the Drupal portal. There is the ticket system, access this help at futuregrid.org. We have a lot of the support staff is you are around. I think they've gone to the other room because there's not enough room in this not enough space in this room here. I should say that the software to support FutureGrid is sort of new because it's not terribly usual to be able to repurpose nodes of a given cluster. Most people keep the same base environment and add to the runtime, whereas in FutureGrid we actually change them back and forth between various uses. We go between Eucalyptus and HPC and OpenStack, depending on how much we want to use of those systems. So we have a strong collaboration between system administration and software. Just as an example, here is the types of usages. If you look at the 223 projects, they're divided between computer science, education, systems evaluation. A lot of the testing of Exceed is done on FutureGrid, and also applications. I note if you look at the applications, somewhat over half are actually in the life sciences, so that's illustrated by the point I made, that life sciences is not only suitable for clouds. I hope Michael's talk showed you that clouds were suitable for at least a lot of important genomics work, and but also life sciences have a lot of new applications. All of Michael's applications are ones that have only really become important over the last 5 years, in that genomics has been revolutionized by the sequences he described. So new applications use new technologies.